we go. So I will step out a bit of the Neos universe and the content management universe, and we'll step into some infrastructural parts. But in the end, so I hope this is not boring you, but I hope in the end I can give you some possibilities how that approaches we using here can affect and empower you when you will step or when you use Neos in an enterprise environment. So first of all, I think most of the guys already know me. My name is Stefan Willkommer. I'm co-founder and CTO at TechDivision. So I do live with my wife here in that area, so 10 kilometers away from here in the front of the Alps. And the cool thing is, maybe you figure out we have our office also here, so it's below the channel and across the channel. And if you would like to have a look at our offices, please talk to me, don't hesitate. I'll show you around, feel free to ask. So yeah, first of all, I had that topic in my presentation, what is enterprise, what is enterprise, so how we define enterprise. It's, I think, an omnipresent phenomenal buzzword we always use when we want to have explain something big. But what we see is that enterprise most of the time comes to some dedicated points, and we figured out that there are three points would always happen when we are talking about enterprise, and that means in enterprise environments we always have a lot of servers. So clustering, cloud is not always, or it's normally there is not only one server but many. And secondly, we have to serve more users. We have to a lot of users we need to serve. And finally, it's all about transactions. So normally, if you have a lot of users, then a lot of users causing more transaction. And a transaction can be everything, as I said in my presentation in the morning. It can be in the environment of e-commerce, but also in classical web environments. So finally, it implies it is a lot of money in the game. And what is the problem here? The problem is we have to deal in such environments with a lot of numbers and a lot of things. And one is, for example, in an enterprise content management environment, is that we have to serve a lot of records. We have to deal with a lot of records, more than 1 million, for example. We have to import data, and that can cause problems. And as I said, it's normally a multiple server setup we are using, and volatile traffic peaks. So that means you have some traffic peaks during Christmas time, for example, or up front of Christmas time. You have to have a lot of traffic, for example. And another problem we see is the caching thing, increasing caching dilemma, because caching sucks. We have to cache sometimes, but caching sucks. So let me show you what a classical infrastructure, and I know you are aware of what a classical infrastructure is or was. Let me show you how we deal with that, or how we set up stuff. Let us step back in time. Classical setup looks like the following. So we have a load balancing layer with some security stuff like web application firewalls. We're using caching environments like Warners, for example, in front of a web server, and of course we're using PHP, FPM, and then we have a service layer where we're using timeless services like Chronos, stuff like that. We use, of course, databases, Memcache like Redis, and message queues sometimes if we want to process asynchronously. And what we are doing when we are in a multiple server setup, we scale out that stuff. So if the traffic is increasing, we scale that out, and that looks the following. And in that bigger setup with higher requirements, that causes also an overhead of management, administration, as well as configuration. So such setups are really hard to configure, or you have to spend a huge amount of time to configure such setups. So, but it's working. What's wrong with that setup? Basically nothing. But if you think outside the box and look in other languages, in other setups, in other areas and fields, it's always good if you do that, because this is what drives innovation. And that's what Neos did as well. So the guys from the core team always are open-minded and look into other languages and were influenced and inspired by other technologies. And so when we look to other languages, especially Java, Python, Ruby, or maybe JavaScript, we see that they have something we do not have in the PHP world. So what they have normally is they have some infrastructural components we don't have. And I mean infrastructural components which are based on the language your application is based. So Java, for example, you have your application servers like Wildfly, JBoss, and so on, or Glassfish. In Python you have the same. You have SOAP, or in Ruby you have Rack. So there are infrastructural components based on the language you are using, and I think this is a cool approach. So, and now, what do we do with that information? Now we are knowing that other languages have infrastructure based on the same language the application is based. What do we do now? So imagine if we can, or we could use an infrastructure, or we can build up an infrastructure on the language your application is written, and the application you love, the language you love. So that's it. That's what you should imagine here. So possibilities. When we want to build up an infrastructure, we have a different kind of possibilities. And the first thing you need for infrastructure is asynchronity or parallelity. And there are three approaches to gain that, and one is the event loop. So if you want to gain asynchronity, you can use event loops. It's quite popular. For example, in JavaScript and PHP we have something like React PHP. So there are event loops normally are available in all operating systems. And then there is another approach, it's forking. So forking is something we call multiprocessing and is also available in PHP. There is an extension in PHP, it's called PCNTL fork, but it is only available in Linux or Unix. So, and then the third possibility is threading, of course. So I think everybody knows so far what threading or multi-threading is, but I will show you exactly how threading is working and how you can use the power of threads. So, what is a thread? So when we look at the model, the process model without threads, then you see the following here. You have your process, and the process consists of your static memory, the program, the register, and the stack. And if you look to the process model with threads, you will see pretty much the similar thing, but you see that the program is generally available, and the thread encapsulates register and stack. And that means that your program can run in that and can share, or the threads can share the memory you use or you can use. And that is, I think, a great difference, and we will talk and we will step into that later on what that power, or how powerful that is and can be. So, if we want to use threads in a PHP userland environment, what do we need? First of all, we need PHP 5.3. So I don't think this is a big problem. Then we have to compile it thread safe, of course. So that means you have to set the flag enable maintainer set yes. And then you need another library which gives you threading in the userland, and this library is called Pthreads.
And we have to really say thank you to Joe Watkins, a PHP core developer who did this incredible library, Pthreads, which is based on the POSIX thread implementation. And that is a cool thing because POSIX threads are almost available on every operating system, including Windows. So you can use threading or the library in the PHP environment on all platforms. So that, I think, is really cool and great. Okay, so now we have set up, or we have the possibility using threads, and with threads we can implement infrastructure, for example. Why can we do that? I will show you how we can do that. So what we can do now is we can use some userland specific objects based on the Pthreads library, and that means we have some userland clauses we can use, and that is threads, for example, stackables, and we can use workers. And now I have some code examples here. You can also have a look at these examples on GitHub. So if you install a runtime which is thread safe and has the Pthreads library installed, then you can have a look at these examples and run that. So first example is my first thread. So it's a pretty simple one. What we do here, you can see that here, we extend from the main class from the thread class, and we are increasing in that loop, we are increasing a counter up to 100,000. And then after that we are running that script, and when we look to the console, to the output of that, you will see that the script finished before the counter was raised. So why was that? If you look again to the code, you see that we start the thread and then we echoing the finished script, and the script is still running, and then afterwards the script is echoing the counter. So that means we have here asynchronity. So pretty simple, but if we go ahead, this can really be powerful. Okay, so I mentioned the stackable concept. What is a stackable? So a stackable allows you to share data between threads. So, and that gives you access to the shared memory. And you can use stackables in a worker context, and it can be seen like a task that has to be processed. So, yeah. Another thing you can do, or you can share in that context, is everything which is serializable. So I have another example here for the stackable. So this is a bit more complex. So what we are doing, we're trying to implement the downloader, and the downloader should download 3 files in parallel, and then should use a stackable to measure the download time and store the download time in that stackable, and then output that data, or that the download time of how long the download took to the console. So, and if we are doing that, here you see the initialization of the script again. So just go to GitHub and test that. That's pretty nice. So you see here, you see here the thread, the output of the script. You see that the downloads take place, and they are running in parallel, and the amount of time, how long the download took, will be stored in the stackable, and then it will be outputted to the console. And the cool thing is here that the stackable itself will be synchronized by the thread magic. So you do not have to take care about the synchronization itself. You have to take care of something else. I will show you what you have to take care in that environment then. So, to go ahead, what is a worker? I talked a bit about the worker concept, or I said something about the worker concept.
a worker is kind of a thread with one significant difference. So the payload will not be passed to the constructor, but to a stack method. So it is more, a worker is more like a queue, so you stack your data on it. Works pretty much more like a queue. And with the worker concept, you can do something, or you can stack something on that, like requests. And that enables you later on to build up something like a web server or something similar. So another thing I mentioned is with the stackables, or what you have to take care on the stackable environment, is the concurrency handling. Because synchronization comes along with the concept of threading, but you have to take care of the concurrency. And there are several concepts how you can take care of that, so you can not run into some deadlock sort of stuff or race conditions. And one of the concepts is the join method. So you can use join waiting for threads. And oh, sorry, that was one click too much. So and then you can use some strange with my slides here. Oh my god. Okay. Okay. Again, sorry for that. Some slides seems to be missing. So, but you have to make sure that the result is available in a thread, and you can also use for that another method, which is the synchronized message. So you can synchronize your data with the synchronized message. I have some examples on GitHub, you can have a look at that as well. And another possibility in that environment is sharing resources. And sharing resources is another cool concept, because it gives you the possibility to share something like sockets, for example, or streams. And then that is the start how you can, or how the possibility is arriving to implementing a web server. So now we have seen some code and some stuff, how you can use thread in the PHP threads and these concepts of stackables and threading in the PHP userland, what to do with all these possibilities. Yeah, you can build an infrastructure on it, for example. So that means you can build up a web server. Sure thing, we do that. And there is a project which is the, maybe you've heard about that, it's the App Server IO project. They did that, and a couple of my colleagues did that. And what they had in mind, or what the vision was here, is to build a completely infrastructure for enterprise environments, and that means it should include, of course, a web server, but a couple of other services. And here is the vision, and I will tell you what exactly isn't actually working and how you can use, or what you can use with Neos at the moment. So, first of all, the vision includes something like a load balancer. So this is just a vision and not implemented yet. But what is happening, or what it's already built up, is a web server in the environment, or in the stateless environment section, and that means it's a classical web server, HTTP, fully HTTP compliant with a fast CGI interface. That means you can use your own PHP FPM module. There is one which is coming along, but you can also use your PHP FPM from your system, or you can also use HHVM, also a possibility. And so you can use that stack, it's fully written in PHP, and you can use that just to serve your PHP-based applications. But there is some more, and the good, or the cool thing is here, we have a section below, it's the in-memory section, the stateful section, and there we have the servlet engine, and the servlet engine concept is, I think, pretty cool and pretty powerful, because it enables you to increase the performance of your web application. What you can do with the servlet engine, you can load all, or the complete implication into your memory, and that means you do not have to bootstrap the application on every request. And this is completely against the shared nothing principle, of course,
but it is very powerful and it definitely can increase your performance. And then here there is a message queue, so you can use that to just push some messages, which are some small objects you can push to it, and you can run then asynchronously. And also there is a timer service available, and the timer service enables you to run some methods of your application timed, and you can configure that by over an annotation in the doc header of your method. So this is also a pretty cool thing, I think. And below there is the persistence container, and the persistence container can hold objects, PHP userland objects in memory. So the data grid is also kind of a visionary thing, because that should enable later the app server node to scale out. So over the data grid we want to scale out all the data to other nodes. So, but this is not implemented yet. Okay, here is the architecture itself, and the cool thing on that stuff is you can add your own components here, because everything is written in PHP. So this is, I think, the really amazing part here. The app server comes with a runtime, so if you install the app server project, then you have your own PHP runtime, which is thread safe and comes along with the Pthreads library. And then you also have integrated the application server itself in the runtime, and it's storing it. And then in the application server there are containers. And in our container we are using, there are 3 servers, and one is the web server, and one part of the web server is the servlet engine. It's just a module for the web server, but we have some great APIs. The app server has some great APIs, so we can extend the web server itself by writing PHP code. And that is, I think, really cool, because you can do something like you can write your own rewrite engine, for example. So we did that for a project. Imagine you have 50 million rewrites, and some other community projects are doing stuff like that, having a lot of rewrites in the database. And what you can do here, or what you can imagine, just write your own rewrite engine and using maybe a NoSQL database to load these rewrites very fast. And then we have, as I said, we have the persistence container server, which is very cool, because you can use message and sessions beans inside of them, and you can use the timer service, which is a part of the persistence container, persistence server, and the message queue server as well, as I said. And you can address them over some protocols here, over HTTP, for example. But we have a cool API, so you can use, or you can implement all protocols you want to use. For example, if you want to have a stomp protocol for a message queue, you can also implement that in PHP. Okay, let's get started. When we want to run Neos, for example, on the App Server IO, it's not a big thing. You just download App Server IO from the App Server IO webpage, download it on any platform. So it is available for Linux, so that means we have a Debian repository. It's available for CentOS and Fedora, and of course you can use it on Windows, so it works pretty fine on Windows as well. And just download it, install it, the installer. Of course it runs on Mac too, because we are the complete company is running Mac, so you can use your Mac, of course, and download the installer, install it, and then you will see after installing the welcome page with all the tutorials how you can go ahead with it. And then you just have to download Neos and drop it into the web apps folder, and then looks the following. If you install the app server on Mac, for example, you will it will install completely on /opt. So that means it doesn't affect any other components you have running, and it is not running on port 80. It's running on port 9080, and you can run it in parallel with Apache or Nginx or whatever you want to use as a web server. so it does not affect any other components you use. So you see that structure here, and on the bottom here you see the folder web apps. So, and if you drop your app into your PHP app into the web apps folder, you can run it just by typing into your browser localhost 9080 port 9080 and then / and the application name. So if you want to drop Neos into it, it will look like the following. So we have just when you install it at the first time, you will see that we have an example app here running, and you can have a look at the example app, because in the example app we have a lot of cool examples how you can use all the services. So that means there are examples using the message queue, the timer service, persistence container, and even servlet examples. So just drop it then. And that's it for the moment, but then you have also set up a vhost. And this is also pretty simple. The app server is configured over an XML file, so we have a virtual host XML file, and you just drop that snippet from the web page, from the tutorials, into the virtual host file, and of course you have to configure the host neos.local in your hosts, etc hosts, and yeah, that's it, and then you can start your installer. So you may ask now, what is the advantage from that approach to maybe using an Apache? First of all, if you run it on Mac, it is faster in comparison to your local Apache, which is initially delivered with a Mac. Why is that? It's pretty simple, because we have a pre-configured PHP FPM, and it's completely optimized for that project. So if you run it on your Mac, it will be faster than the standard Apache, which comes along with the Mac. Okay. If you compare it to Nginx, for example, and you're doing the configuring right on Nginx, it might be a little slower than Nginx, but it's not a really big difference, because legacy apps or normal standard apps which are not using any advantage, just using the web server, cannot be really faster. So we are working on having some socket library stuff integrated, some new socket library stuff, and then we think we'll have a pretty same performance than Nginx or Apache with PHP FPM. But if you implement servlets, and that is what could be a next part, so maybe not from us, but maybe one of the community, or maybe from the core team will do that, then we can increase the performance tremendously. So that means we wrap Neos, for example, into a servlet and run it on startup of the app server, and then on request we do not have to bootstrap anymore. So what's next? That could be maybe something we can have on the next level or on the next stage. So running Neos as a servlet would be an absolutely powerful approach, because Neos is doing a lot of stuff because of the architecture, which is a pretty cool and good thing, but when it comes to performance, that can be something like lag, and caching is not always a good option, as I said initially. So what you can also use is, for example, the message queue for import scenarios. So if you import data, maybe from, and hopefully that will happen in the future, that we have to migrate a lot of Typo3 CMS projects into Neos, and we are already doing stuff like that. You want to import data, or we have to run it parallel sometime, and you have to synchronize data maybe. A message queue is a good approach for doing something like that. And what you also can imagine is something like cache warm-ups and cache management over App Server IO, because you can use the message queue here, or you can use timer services and so on. So that would be also a cool approach, I think. Okay, what are the next steps for that project? The project basically is completely available on GitHub, so just
look at GitHub App Server, you will completely find that. Our project is completely open. It's, I think, good or quite well documented, so there shouldn't be any problem running Neos, for example, on it. And we got a lot of feedback from the community, especially from Type 3 Neos community, which is pretty great, because when you build up an infrastructure, it's not that easy, and you need that feedback from the community. What would be good in the product, and how the product can be evolved, and so on. So I really invite you to try it. Just try it, because it's really simple to install. And yeah, make up your mind. Let us know what you want to have in it, and I think it can be a really powerful setup for the future, for enterprise environments, because we are having some concepts what we want to implement over the next year. So we have a roadmap, and we want to implement cluster support, for example. So something like Elasticsearch is doing. So we want to really implement a really nice and easy cluster setup. That means that you just put another server in your network, and the app server IO is taking care of all the setup scenarios and sharing the application. So that means we will integrate something like farming deployment. And that is also, deployment is also a cool thing here, because it is already available. You can deploy Neos, for example, as a FAR file. So that is possible with pre and post installation conditions. So you can do that, just deliver your application as a FAR. And we also are thinking about having a dashboard for the server, so you can go to your browser and configure all the stuff you're doing in XML right now on the dashboard. So these are the concepts we have in mind. I think there's a lot which is coming in the near future, but the next step is the version 1.1. So we released 1.0 a couple of weeks ago in February, and the 1.1 version, which will come, or which will arrive in May 2015. So also in a couple of months. Will completely support PHP 5.6. So actually we are running on 5.5, but with the 1.1 we will use then PHP 5.6 and the new Pthreads version 2.x. So yeah, that's it so far. If you have any questions, just ask. I'm around later on the Markthalle and the cafe as well. So hopefully we can get some feedback out from the community. Please give it a shot, because we really think that it can be a cool approach to have infrastructure which is implemented in the language we implemented our application. So that's it so far from my side. Thank you.
Thanks a lot, Stefan. Are there any questions? I see that the whole App Server IO team is present, so shoot your questions at all of them. No matter how hard they are, they will be able to answer them.
I don't think so.
Let's see. Okay, yeah, question in the back. I'll start with this one, because he's closer to me.
Come on. Hans, you already know everything. I don't have to answer.
No. Okay, good. So what I'm thinking of is building a servlet where we build a really tight API service, not having to bootstrap an entire framework to be fast using Elasticsearch as a data backend. But at some point we might need something like front-end users, applications, ACL, and so on. And then I think about bootstrapping the Flow framework for this. So is it possible to have a combination of API REST servlet endpoints and the routing of the Flow framework, which serves an API through the framework? So you have a path through and bootstrapping the entire framework together in one routing set?
It's a good question. I can't really answer that because we have tried Flow and or running Flow applications, or for example running Neos in a servlet, but we figured out some problems which were related to some really core stuff. So we had no chance to fix that right now. And we have also figured out that we will have some other problems with other frameworks as well. For example, we tried to get Laravel applications into a servlet, and it does not work because in 5.5 or in the version we are actually using, which is 5.5, PHP 5.5, it is not possible with Pthreads or with the Pthreads 1 library to have closures as a member in clauses, and Laravel, for example, is heavily using that, and a lot of other frameworks as well. So the problem is that most of the frameworks, and I don't want to say that in a bad word or with bad intention, is that they were not aware at the point of time when that was written that something like that kind of infrastructure came out. And so most of the frameworks out there, and that is for Neos and Flow, it is the same, have to be refactored in some ways, and the problem is here that we can, or we do not have the power to look into all those issues. So would be great if you can try it, and if you have any problems with it, running it, or have some problems with the conceptual things, just drop us lines in our GitHub chats. So we have an open GitHub chat, so everybody is invited to ask us questions there. It's a pretty open project, so just drop us some questions, and I'm pretty sure the guys can have a look into it when you're ready with it. So yeah, and if you have, or if any of you have any bugs with the project, just push it or use the issue track on GitHub. We are heavily using that, and yeah.
I'm joined from the core team.
Yeah.
It was everything all right with the things you told, but just maybe one simple thing you can do is using Neos as fast CGI backend service, so you can configure the web server via location to handle several URLs via fast CGI and go to the Flow framework as normal as you would do via Apache, and let the RESTful servlet stuff be handled from the app server. That would be the solution that is available right now. The other solution maybe is a little difficult. We tried several things, putting Flow into the bootstrap of a servlet, or keeping the bootstrap done before the request handles it, and it's more about Stefan said, because the old or the frameworks which are not built upon stateful things aren't compatible. So I hope this gives you a quick solution. Maybe in the future we have another solution. Thank you.
Thank you, Hans.
All right, another question?
Yeah.
Yeah, so first off, I think I can speak for the Flow Neos team that we would be really happy if we could solve these issues in the core as well, and we would help out on that as well at some point, so I think we need to coordinate on that. Obviously I don't know how easy or difficult it is, but probably we get further at least on that. And so now my question, did you think about implementing, for instance, a WebSocket support in that server? Because for Neos, for instance, we are thinking about push notifications to end users, and we could imagine that would really help us actually.
We already had one, so a Ratchet, but we had some problems with it, so as we wanted to have, as we Germans are, we wanted to have a really stable 1.0 version, and that was the reason why we pulled it out of the project. But we were definitely thinking of self-implemented WebSocket server. Correct me if I'm wrong, Hans. Maybe you are a bit deeper into that, into the roadmap for that. So maybe you can ask directly to Sebastian.
Yeah, of course. We had the problem that socket library in PHP is wrapped about resources, and resources are by now shareable, but not really. In that way, you can really share some socket stuff, and we are working on a socket library by ourselves, which is a little faster and a little lightweighter. So, and it's built to be shared. So in the future, we will, when we finish the socket library, we will build up upon a WebSocket server, which can be handled as a node WebSocket server. So, was that okay, Stefan?
For me, pretty much okay.
Thanks.
No, again, that's what I was saying during the talk. Hans is working on a library which is called Rockets. It's a socket library for PHP, which is fixing some stuff and is much more performant than the PHP socket implementation right now is. So, and that will maybe give us then a performance on the web server which is pretty much the same as Nginx. But again, it is for a PHP. And you have to think about that. For PHP, it is pretty fast right now, so it's not slow. The web server is really fast, so you will definitely do not have any performance problems actually. So we have running some customer projects live on it, and we do not have any problem with regarding performance. So, and if you use, for example, App Server IO with HHVM, it's a pretty cool approach for, we call it legacy apps, so apps which are just PHP and are not built up for that kind of architecture. So any more questions here?
Yeah, here, in the back.
Yeah, I'm not sure if I got everything right, but as far as I understood, you have some pretty long-running PHP tasks in this concept. So what is your experience with kind of memory management and garbage collection in PHP when things are running really long?
So we did a lot of research at that. So we started 2 years ago and figured out that there are some conditions. For example, we have some seg faults, of course, when you do not do things right. But right now it's pretty stable. That's what I can say. So we do not have any problems. It's running, and the concept basically is the good thing here is that it's completely uncoupled. That means that if your application, for example, is running into an exception or an error, it does not affect the server. So because it runs in your own thread, so we would just throw it away and start a new one. So the app server IO can only be crashed when you have a seg fault, but that would be the same on any other web server. So you can, if you want to, you can also let Apache crash or Nginx crash when you're provoking a seg fault. So that is also possible in that servers as well. So we haven't figured out any problems right now. So we did a lot of testing, and we also did or give some of our testing or what we find out during our testing. We gave all the information back to Joe, for example, from the Pthreads library, and yeah, right now, from our point of view and from our side, there are no problems by such a long-running script as you said. So.